Glad you could join me. Today we're going to be talking about discrete probability distributions. Now, a probability distribution of a discrete random variable provides all possible x values that the discrete variable could take on, plus its corresponding probabilities. Now, a probability and a probability distribution, they must abide by two general conditions. First, that each probability must range between 0 and 1. Now, if you think about it, it makes sense. You can't have a negative probability, nor can you have a probability greater than 100%. The second condition is that the sum of all of our probabilities within a probability distribution must total 1. All of the events that are occurring, or all of the different ways that the events could occur for our random variable, must total 100%. And that's all we're saying here, that the sum of all probabilities must equal 1. So let's look at our data. We have following data that represents the number of games played in each World Series from 1923 to 2005. Our random variable x is the number of games that were played for each year. Now, our random variable x can take on the values of 4, 5, 6, or 7. This is our sample space. These are the discrete values of our random variable x. So the first step that we need to find is to compute the probabilities for each of these discrete values. To do this, we're going to sum up all of the frequencies or counts for each discrete value of x and then compute the relative frequencies. So let's work through the steps for the probabilities. For the discrete value of 4, we're going to use the sum of all of our frequencies, which in this case totals up to 82. We're going to compute the probability by finding the relative frequency. 16 divided by 82 is going to equal 0.195. We're going to do the same for each of the values of x. 15 divided by 82 will give us a probability of 0.183. 18 divided by 82 gives us a probability of 0.220. And the last value of x is going to be 0.420. Now that we have all of the probabilities for our distribution, the next step is to compute the mean of our random variable x. Now, this is very similar to a mean that you would compute using sample data, where you would simply sum up the values and divide by n. We're going to do the same thing, only we're now going to weight each of the values of x by their probabilities. And if you think about it, a probability is nothing more than a weight. Those values of x that have a higher probability would occur more frequently and should be weighted accordingly. And that's exactly what we're going to do. So let's work through the steps to compute the mean of our random variable x. Now, I've worked through most of the steps for you and have written them out. And what you see is the original equation to compute the mean. It is simply the summation of x times p of x. we simply step through our probability distribution multiplying x times its probability. We then do the math, and we come up with a mean of 5.829. This mean is also referred to as the expected value. This is the value we would expect to occur if this experiment, this probability experiment, was repeated over and over again. Once we have this mean or expected value, the last step is to compute the variance and standard deviation of our random variable. Now let's step through the problem and compute those values. As before, I've done most of the work for you already. What you're seeing here is the variance of the random variable x. You simply sum up the square of each x value multiplied by the probability. And then, in the end, we're going to subtract the square of the expected value. Now, as I have stepped through the probability distribution, squaring each x value, multiplying it by its corresponding probability, you'll see I have simplified along the way. The final step being the subtraction of the mean. This resolves into 35.313 minus 33.977. The variance of this random variable x is then 1.336 games squared. Now, while this is a useful statistic, the units are squared, and it can be often difficult for us to understand that. So we're simply going to take the square root of our variance to get the standard deviation. Let's do that now. If we take the square root of 1.336, this will give us the standard deviation of 1.156 games. We now have the mean, the variance, and the standard deviation of our discrete random variable. I hope this has helped your understanding about probability distributions when you have a discrete random variable. Thanks for joining me, and hope to see you next time. Have a nice day.